Hello, this is Math Jazz from Almost Cool. Today, I want to go over some practice exam questions that my students my students have an exam next week, and these will be some practice questions for that exam. Again, if you have any questions that you'd like me to answer, then please email them to me at mathjazz9@gmail.com or type them into the chat in the live stream. So, without any further ado, let us move um, to our camera. Okay, so we've been doing some linear programming, and so we will have some exam questions on that. The first question is an exam question on linear programming. So I'll read the question to you. It says, a wood carver makes toy boats to sell at the fair. A simple sailboat requires 1 linear foot of wood and 40 minutes of labor, whereas a fancier tugboat requires 2 linear feet of wood and 90 minutes of labor. So let's see that. So a sailboat is 1 foot of wood and it is 40 minutes of labor. And a tugboat is 2 feet of wood and 90 minutes of labor. Carver has 100 linear feet of wood and can spend at most 50 hours making tugboats. So that means that if we use X to represent the number of sailboats and Y to represent the number of tugboats, so this is our variable, that means that X plus 2Y has to equal 100 because the number of sailboats times 1 foot of wood plus the number of tugboats times 2 feet of wood per tugboat gives us this as our restraint. Well, less than or equal to 100, because he might not be able to use up all of the wood. And then the other constraint is time. So 40 minutes of labor says that they have at most 50 hours work. So 40 minutes of labor is 2/3 of an hour per sailboat plus 3/2 of an hour, 90 minutes per tugboat. So 3/2 of an hour per tugboat has to be less than or equal to 50 hours of labor. Okay, so the profit that we're trying to get, profit will be Z is equal to $12 per sailboat plus $18 per tugboat. And now we have to find the maximum profit that he can make given his time constraint and his wood constraint. So, with this, what we want to do is we need to set up a linear system. So, this constraint will become 1x. So here's our x column, our y column. We have 2 constraints, so we need 2 slack variables, s1 and s2. We have our z, and we have our constant. So we have 1x, 2y, our slack variable for our first equation. That's the slack variable for the second equation, so it's not in the first equation. Z is also not in the first equation, and our constant is 100. The next row is going to be, I'm going to multiply through by 6 just to get rid of the fractions. So 6 times 2/3, 6 is 2 times 3, 3 in the top and 3 in the bottom, cancel, leaving me with 4. So we have 4x, and then we have 9y plus our second slack variable, because this is a second constraint equation. There's no z in here, and 6 times 50 is 300. And then our our objective function is going to be the bottom row of our matrix. So we have negative 12z, negative 18y, no slack variables, and 1z, and the constant is 0. So this is called our simplex tableau. Now, what we do, the first step, if we pull up our method from Tuesday, goes like this. First, we find the most negative indicator. If all of our indicators are positive, we're done. So, looking at our indicators are the bottom row except for the last entry. So, our indicators are these 5 numbers, negative 12, negative 18, 0, 0, and 1. We look for the most negative of them, which is negative 18. That tells us that the Y column is our pivot column. Now, we move on to the next step. We find the smallest positive pivot ratio. Pivot ratios are constant term over corresponding pivot term, or constant entry over corresponding pivot entry. So 100 divided by 2 is 50. That's the ratio for the top row. 300 divided by 9 is, well, that's like 33 and change. So that's the ratio for this next row. And then 0 over 18 is 0. That's our ratio for the bottom row. But we only care about the positive ratios. 0 is not positive. And so we only look at the 50 and the 33 and change here. 33 is less than 50, so our second row is our pivot row, making this our pivot. So Y column is the pivot column, the second row is our pivot row, 9 is our pivot. And what we need to do is we need to remove all entries in the pivot column that are not the pivot. And we're only allowed to use row operations that include the pivot row. So, looking at this, I want to get rid of this 2. So, what I'm going to do is I'm going to go 2 row 2 minus 9 row 1 goes to row 1. By doing that, I will remove this 2 because I'll have 2 times 9 is 18. Negative 9 times 2 is negative 18. Adding those together gives me 0. I also want to get rid of this 18. So 2 times this second row plus the last row will get rid of my last row's 18. The 2R2 plus R3 goes to R3. Okay, so after figuring out what I need to do, we will execute this. So our middle row does not change because that is our pivot row. 4, 9, 0, 1, 1, 300. Our top row will be 2 times the second row minus 9 times the first row. So that is 2 times 4 is 8, minus 9 times 1, so 8 minus 9 is negative 1. We already chose our coefficients, so that would be 0. We have 2 times 0 is 0. Negative 9 times 1 is negative 9. So we get negative 9. 2 times 1 is 2. Minus 9 times 0 ends up being 2. 2 times... this tableau is incorrectly formatted. There should be a 0 here because there's no z in the second constraint function. We've caught that and we've fixed it. This is a 0 here. So 2 times 0 plus negative 9 times 0 is 0. 2 times 300 is 600. Negative 9 times 100 is negative 900. 600 minus 900 is negative 300. And then we do the same thing for our bottom row. So our row operation is 2 times the second row plus the third row going to the third row. So 4 times 2 is 8, minus 12 is negative 4. 2 times 9 is 18, minus 18 is 0. 2 times 0 plus 0 is 0. 2 times 1 plus 0 is 2. 2 times 0 plus 1 is 1. 2 times 300 plus 0 is 600. We look at the most negative indicator, which is this negative 4, since it's the only negative indicator. So that means that this first column is our pivot column. We look at our ratios. Negative 300 over 1 is 300. 300 over 4 is 75. And 600 over negative 4 is negative 150. But negatives don't count. Only positive ratios count. So we throw out the bottom row. We have 75 is less than 300. So our second row is our pivot row. So this means that this is our pivot. I want to remove all entries in the pivot column, that is the leftmost column, that are not the 4, the pivot 4. So I have to figure out what to do. I decide, well, R2 plus 4R1 goes to R1 will work, and R2 plus R3 going to R3 will work as well. That'll get rid of the negative 1 and the negative 4. So now we move on. Our second row does not change. 4, 9, 0, 1, 0, 300. 4 minus 4 is 0. 9 minus 0 is 9. 0, we're adding 4R1, so negative 9 times 4 is negative 36. 0 minus 36 is negative 36. We have 1 plus 8 is 9. 0 plus 0 is 0. 300 minus 1200 is negative 900. Moving on, get 0, because 4 minus 4 is 0. 9 plus 0 is 9. 0 plus 0 is 0. 1 plus 2 is 3. 0 plus 1 is 1. 300 plus 600 is 900. So, we no longer have positive indicators, which means that we are done with our simplex maneuvers, and we now have to figure out how to read the answer from this. So, what happens is every column that has more than one non-zero entry, so this column and this column, those variables end up being 0. So we have x, y, s1, s2, and z are our variables. And what we know is that y is 0 and s2 is also 0. Now for our other variables, those are the ones that are called basic variables. So we have, this row has only the 4 in it, and so 300 over 4 is our value for x. That's 75, because 4 is in the x column. And 300 is the constant term that corresponds to the only non-zero entry in the column. We move on to the next one. 900 over 36 is, or negative 900 over negative 36 is the same as 900 over 36, which is the same as 300 over 12, which is the same as 100 over 4, which is 25. Okay. And then our z, this is our z column. We have 900 over 1 is our value for z. So what this tells us is that he could make $900 of profit if he makes 75 sailboats, no tugboats, and spends 25 hours of time doing nothing. So That is how we do this problem. And we move on to the next answer. Let's see. Our next question is going to be, in a steel lumber economy, it takes 0.02 units of steel and 0.05 units of lumber to produce 1 unit of steel, whereas it requires 0.06 units of steel and 0.06 units of coal to produce 1 unit of lumber. How many units of steel and coal must be produced to satisfy the external demand for 20 units of steel and 10 units of lumber? So let's add those up. We have 0.2, this is 0.2 units of steel and 0.5 units of lumber to produce 1 unit of steel. So this is steel, this is lumber, this is coal, and this is steel, and this is lumber, and this is coal. To produce lumber, it requires 0.6 units of steel and 0.6 units of coal. And we don't have information on how much coal it takes, or how much it takes to produce coal. Okay. However, we want to produce 20 units of steel. Want 20 steel, and we want 10 units of lumber. So, to produce 20 units of steel, we need 20 times 0.2 units of steel plus 0.5 units of lumber. And to produce 10 units of lumber, we need 10 times 0.6 units of steel and 0.6 units of coal. So we multiply these through. We get 4 steel plus 10 lumber, and we get 6 steel plus 6 coal, which gives us a total of 10 steel, 16 lumber, and 6 coal is what we need. Okay. So, our next question. Find the maximum of z equals 10x1 plus 15x2 plus 10x3 plus 5x4, subject to the constraints all of our variables must be greater than 1, x1 plus x2 plus x3 plus x4 is less than or equal to 300, and x1 plus 2x2 plus 3x3 plus 4x4 is less than or equal to 360. Okay, so to solve this problem, we set up our tableau. We get our first row is going to be 1, 1, 1, 1, 1 slack variable, nothing for the second slack variable. We need 2 slack variables because we have 2 constraint equations. And then 300. We get 1, 2, 3, 4, 0 on the first slack variable, 1 on the second slack variable, and 0z, 0z. And then 360. And we have -10, -15, -10, -5, 0, 0, 1z, and 0 for our simplex tableau, coming from these three equations. From here, we find the most negative, which is -15. And we get 300 over 1, which is 300, and 360 over 2, which is 180. The last one is 0, so we don't care about it. So our 2 is our pivot. We have to get rid of the 1 and the -15. So what we want to do is do 2r1 minus r2 goes to r1, and we want 15 r2 plus 2 r3 going to r3. Okay, so we don't change the second row, 1, 2, 3, 4, 0, 1, 0, 360. Our first row is going to be 2 times the top row minus the second row. So 2 times 1 minus 1 is 1, 2 times 1 minus 2 is 0, 2 times 1 minus 3 is -1, 2 times 1 minus 4 is -2, 2 times 1 minus 0 is 2, 2 times 0 minus 1 is -1, 2 times 0 minus 0 is 0, 2 times 300 minus 360 is going to be 240. That's our top row. Our bottom row is obtained by 15r2 plus 2r3 to r3. So 15 minus 20 is going to be -5. 30 minus 30 is 0. 45 minus 20 is 25. 60 minus 10 is 50. 0 minus 0 is 0. 15 plus 2 is, 15 plus 0 is 15. 0 plus 2 is 2. And 15 times 360 is a large number. 360, 15, we get 3, 6, 0, 0, and we get 1, let's see, 1, 6, 8, 0, adding up to be 0, 8, 2, 5. So 5, 2, 8, 0 is our new constant. From here, we only have the one negative term. It's this -5. So this is our pivot column. We need to find our pivot row. So we get 240 over 1 and 360 over 1. So our pivot is this top left 1 here. So the top row does not change, but the second row will. So our top row is 1, 0, -1, -2, 2, -1, 0, 240. If we take the second row and subtract the top row, we get 0. So we'll do that. We get 1 minus 1 is 0. 2 minus 0 is 2. 3 minus -1 is 4. 4 minus -2 is 6. 0 minus 2 is -2. 1 minus -1 is 2. 0 minus 0 is 0. 360 minus 240 is 120. So that is our second row. Our third row, if we do 5 times the top row plus the bottom row, we get a 0 here. 5 times 0 plus 0 is 0. 5 times -1 plus 25 is 20. 5 times -2 plus 50 is 40. 5 times 2 plus 0 is 10. 5 times negative 1 plus 15 is 10. 5 times 0 plus 2 is 2. 5 times 240. So here is 240. Here is a 5. We get 1, 200, so 1200. So we get 1200 plus 5280 is going to be 6480. And this is a finished matrix tableau because none of our indicators are zero. Sorry, none of our indicators are negative. So that means that we get x1 is equal to 240 over 1. x2 is equal to 120 over 2, which is 60. x3 is equal to 0 because x3 is a column that has more than one non-zero entry. x4 also equals 0. S1 equals 0. S2 equals 0. And Z equals, since Z is a basic variable, it has only one non-zero entry, we get 6480 divided by 2, which is going to be 3240. So these are our answers. So the maximum value is obtained when we have x1 equaling 240, x2 equals 60, the other two variables equal 0, and that'll end up with z equaling 3240. Okay, so with that, we will end the live stream, and we will come back tomorrow to learn more about simplex tableaus and related matrix problems. So I hope that you're enjoying watching. Thank you again for your support and for your interest in mathematics. Email questions you have to mathjazz9@gmail.com, and I'll see you tomorrow. Bye.